When you have two terms that are both perfect squares and they are connected by a subtraction symbol, you are able to use the difference of squares pattern to factor instead of having to list out A, B, and C and walk through the entire process that we use when there are three terms. We call this the difference of squares. The pattern is that you can take the square root of both terms and set them in their own separate factor and connect them with one addition sign and one subtraction sign. Let's take a look at the first example. For this one, we need to take the square root of y squared and the square root of 16. Notice when we did the square root of 16, we did not take the negative with it. The negative just symbolizes that we can do difference of squares, because remember that difference means subtraction. So the square root of y squared is y. The square root of 16 is 4. So when I go to set up my difference of squares factoring, I need two sets of parentheses. And in the front of each set of parentheses, we'll put our square root of our first term, y. In the back of each set of parentheses, we'll put the square root of the second term, which is 4. And they'll be connected by 1 plus and 1 minus. It doesn't matter which order you put these in. You could have put the minus first and then the plus. It's still the same answer. Let's take a look at the second one. Our first term is x squared, so the square root of x squared. And our second term is 9, so square root of 9. Now, when we are taking the square root of a variable, we are really just asking ourselves what times itself equals x squared. And the answer is x times itself is x squared. So the square root of x squared is just x. That's the same thing that we're doing when we're doing the numbers as well. But remember that there's a button on your calculator that you can use when you need to take the square root of a number. It's second, and then the number right to the left of 7, if you have a calculator that's similar to the one that we use in class. The square root of 9 is 3. So when I set up my parentheses, I have two sets of parentheses. And the square root of the first term, which is x, will go in the front of each. The square root of the last term, 3, will go in the back of each. And we'll make 1 plus and 1 minus. For the next step up, we're going to take the square root of the first term, which this time instead of just one variable, it's a number and a variable, so it has a coefficient. And then the square root of the second term is just 25. So when we take the square root of a number with a variable or a coefficient and a variable, we take the square root of the coefficient, square root of 4 is 2, and then the square root of the variable, square root of a squared is just a. Then the square root of 25 is 5. So we'll set up our set of parentheses. The square root of the first term will go in the first spot. The square root of the last term will go in the last spot. And we'll connect them with 1 plus and 1 minus. Let's do that one more time. We have this 9b squared minus 36. So in order to factor this binomial, we will take the square root of 9b squared and the square root of 36. The square root of 9b squared, square root of 9 is 3. The square root of b squared is b. And the square root of 36 is 6. So we'll set up with two sets of parentheses. And we'll put the square root of the first term in the front of each set. And the square root of the last term will go in the last spot of each set. 1 plus and 1 minus.